Hello there. So this is going to be a quick overview of the project so that you don't get confused about what you need to do exactly. And this is specifically for the project of summer 2025. So it might not be the case later on. So there's that. So the project is about connecting data with decision making in real world engineering or other aspects. So we kept it to climate engineering and health. You will select a dataset from the UC Irvine Machine Learning Repository, a very nice repository that has free access datasets available for everyone. And again, your focus will be climate engineering or health. So we wanted to keep it kind of, to a certain extent, scientific. Your mission is to develop a predictive regression model using Microsoft Excel only. So no other tools, Minitab, RapidMiner, or none of those. Just Excel. Keep it simple. So, but it's not just to model the data as well. You need to interpret the meaning behind the results. You will do some graphs, you will do some exploratory data analysis, and then you need to talk about what does it mean? What did you conclude from that? Show me your understanding. So that's also very important. Also, in the end, you need to reflect on the ethical, societal, and environmental considerations, right? Because making decisions for us in this course is all about these three aspects. Now, here we have a snapshot of the UC Irvine data, like the website, right? The dataset website. And as you can see, I have circled in red three different things. So when you go to data type, you see multivariate circled. You click on that. And then you expand subject area and you have climate and environment, engineering, health and medicine, right? So you select those three as well. Then you will get around 100 data sets that you can choose from. So go through them, find something you think is nice, pick it, and go and work with it. So this is how you find your data set. You need to do this filtering. You go to the UC Irvine database, and everything should be fine. Okay? So after that, what are your tasks? You chose your data set. Now you clean it and prepare it. And we talked a lot about outliers and how we use IQR and SIQR to get rid of outliers. But there are other techniques that you can use, so it's up to you. So once you organize your data set in Excel, perform exploratory data analysis. So use summary stats, scatter plots, and a correlation matrix, for example. All of those which are available in Excel to really clean up and understand your data set. And then build a regression model using Excel tools like trend lines, which are available in scatter plots in Excel, or line EST, which is another feature in Excel. Or there is a regression and that is available in the data analysis tab in Excel. You go to the top, go to data analysis, and you click on it and you do regression as well. Once you get your regression model, it will give you its coefficients. It will give you an equation. It will give you R square. It will give you p-values. It will give you like a whole list of numerical features. So those you need to analyze them and see really what is going on with your first model. And I'm saying first because in PD2 you will make a bunch more. The first one needs to be linear. Now, after that, reflect on 3 to 5 ethical, societal, or environmental implications of using your model. And you developed your initial model. If you want to use it in real life, what does it mean? Like how does it reflect in real life? Is it good? Is it bad? All these things. And then explain if it is going to be useful or is it limited to something? Is it lacking something? Think about that. And then in PD2, you need to try the refinement techniques that are available in Excel, like exponential modeling and pattern detection, logarithmic, all of these features, multivariate regression, which is in the same data tab, but like I think it's the second one underneath it. So, try all these features, play with them. see what is possible. And once you do that, prepare a residual and scatter plot. Check them, see if the model is good or not. Usually a residual graph, if all the residuals are near the x-axis, so near the 0, it means it is good. So is your final model, your final improved model like that, or is it everywhere? So it is not as good as you think it is, right? Do a sensitivity analysis, which is to identify the most critical factor in your data set impacting the final results, and compare your improved model and the original model and decide and reflect and, give your thought on which one is better and why, right? And then reflect again on the broader impacts. Was there any change? Like once you improve the model, was there any change from the previous model? Like, does it change its impact? Is the impact better now? What happened? So reflect, have some thought, think about it. And write your report based on that, right? And update your Excel files. Maybe put like PD1 and PD2 in 2 separate sheets, for example. That would be a good idea, so that you would have your work organized. So some examples of the topics you can use is, for climate, can we predict air pollution based on industrial and traffic data? Like you have a column of traffic data, you have industrial usage data, and then you can predict the air pollution level. That's one possibility. For engineering, what factors predict material strength or energy consumption? Like you would have a list of columns, and then what will be the rate of material strength if it was a material project, or energy consumption if it was an energy-based project. For health, can we model blood pressure based on lifestyle indicators? So we have multiple columns related to lifestyle, how many meals per day, how many times they exercise per week, average steps, and then in the end, blood pressure level and stuff like that. Here, I'm going to go quickly over an example of a data set. So here we have a data set of landmine detection, which is pretty cool. I mean, not the mines, but, the idea of being able to predict where a mine is through numbers. That's amazing. So V is the voltage from the sensors, landmine detection sensors, and H is the height of the sensor, and S is the soil type, right? And then M is the type of the landmine. So imagine that you can make an equation using the numbers in V, H, and S. So the numbers in V, H, and S, and then it would tell you what type of mine do you have. And this dataset is available on the UC Irvine website, by the way. And there are 5 types of mines. And using those numbers, you can accurately predict which type of mines you're dealing with, and each one of them has a certain removal protocol, which is really pretty cool if you can do this very accurately. Like you can predict which mine do you have, and then tell which protocol to use to remove it right away just using numbers. Imagine how awesome this is. So that's generally what your project is about. I do recommend that you start right away, finish it as soon as possible. This semester is so rushed, so be very careful with your time management. And best of luck.